power system engineer. So, what are requirements for a good power system engineers? And next is the per unit analysis and the transmission planning codes, and then the power system components modeling overview in PSSE. So, we will discuss the different components modeling in PSSE in detail. So, as a power system engineer, so one must have all these four qualities to become a good a solution provider rather than a robotic engineer. So the first one is the background of power system engineering. So next is the know-how of analytical software tool like PSSE or PSCAD or Dixieland Power Factory, any tool. So at least you should have one idea, know-how of at least one transmission planning tool. And next is the knowledge of power system network under study. And the last one is the knowledge of problem under study. So as a power system engineer, as a system studies engineer, because the most important point is the as an analysis in the studies. So so you must have all these four qualities, like the background of power system engineering. What is meant by background of power system engineering? It means that you should have complete knowledge of your theoretical concepts like the transmission line modeling, like load modeling, generator modeling, transformer modeling, and three winding transformer modeling. So all these theoretical concepts you should know about regarding this power system components. Next is the know-how of analytical tool. So you should at least learn one tool like the as a power system simulation tool, any tool like Power Simulator, ETAP, or PSSE. And next is the knowledge of power system network under study. So that's very important when you are doing a transmission planning in any utility or in working as a consulting company. So you should have a complete picture of clear picture of the network under study. Like you are working in a Pakistan network, so then at least you should have a idea about the network topologies and networks. The geographical area of the network, where the distribution area is, where the load center available, where are the hydrogen different type of generation available. So this the third point is very important, the knowledge of power system network understanding. At least when you are starting any study on any network, so first get a knowledge about the network on a geographical scale. And the next one is the last is the knowledge of problem under study. Like if you are working on a transmission planning exercise, then you should have a knowledge regarding load flow analysis, short circuit analysis, and transient stability analysis. Like if you are working in a distribution level, then you should have a idea about the reactive power compensation study and power quality studies. So this type of problem you should know. So before going to start the study, so all of these informations are necessary as a power system engineer to carry out different studies and become a solution provider. So if any one of you have a deficiency in four of these, so you can fill these deficiency by doing a literature review about these things. Okay, this next topic is the per unit analysis. So the per unit analysis background is that the per unit system is basically where the different impedance and different quantities are normalized on a common base. So why we do all these things on a common base? Basically, the calculations are simplified, because when we are doing analysis on non-linear algebraic equation, then it will be difficult for an engineer to calculate all these things and do a different iterations in actual units. So we convert all these quantities into per unit quantities. So mostly in the per unit methods, what we do, all the system impedance and net admittance within the networks are converted into common base, and these normalized impedance are known as per unit impedances. And the network of per unit can be solved the same way, the standard network analysis method, the same Ohm law and the Kirchhoff laws and other laws also. So there are four basic base quantity. That the one is the base MVA, and the next is the base KV, and the third one is the base impedance, and the fourth one is the base amperes. Is mostly we say kiloamps also, because at system level the quantity is high, so we say kiloamps. So when any two of four are assigned, so basically If two are known, so we can find the other two base quantities. Then we can find the first we find the base quantities, then we can find the per unit quantities simply by dividing the actual value by base quantities. So somehow mostly in study, so base MVA and base KVAs are given. So how we use these values? No, normally line to line voltages are normally used as a base voltage, and three phase power being used as a base power. So three phase power mean S, the apparent power, like S is equal to under root square root 3 VI. So this is the power, right? This is used as a base power. So in per unit analysis, the first area is three phase per unit equation. So we are discussing the three phase per unit equations, then we will discuss the single phase like DC per unit equations, and then in the end we will discuss the basically the conversion of power of different base powers. So the first process in the three phase per unit equation is that we should have an idea of base value, because once the network data is given, so that are based on the actual values. So we have to calculate the base values of the network. So how we will calculate? As we know that out of four quantities, two are given, we can find the other two quantities by using these formulas. So if we are interested in calculating the base current, so I base is equal to basically the MVA base, like this power base, divided by square root 3, and square root 3 is on due to the three phase equations, and the kV base is the voltage base. So we can first, if we can find the I base, then we can directly find M base power also. So there are different formula, like for base impedance Z base, KVA base is given. We have calculated the current base in the previous equation. Using the current base in from the previous equation, we can find Z base also. And similarly, another formula is given V square over S. So using this formula also we can calculate Z base. So next one is the base admittance, simply 1 over Z base, or we can calculate in the reciprocal formula of Z base. So in this way, if two of four are quantities are given, so we can calculate other quantity like base current and base impedance and base admittance. So all voltages, clear that all voltages are in kV, currents are in kiloampere, and powers in MVA. So in this way we can calculate the base values, right? So next, you have calculated the base values from a three phase actual values. Now we are interested in finding the per unit voltage. Like if we are interested in the per unit voltage, we know the kV actual value and the kV base that we have calculated, or that is given. So initially we can find V per unit, so which is mostly the given, we are using the same, and the per unit power. The now per unit power is very important. So mean if you are finding the actual P, that is megawatt divided by MVA. So not megawatt divided by megawatt. So this is megawatt divided by MVA base. Similarly Q per unit, so megawatt divided by MVA base. Okay, so these two quantities are more important, because mostly and at a student level what people student do, that they simply calculate the P mega, basically megawatt base. So basically the three phase power like MVA base is also a S we can divide. And if you need a proof, I can give you a proof simply, because as we know that S is equal to P plus JQ. So divide S actual divided by S base. So definitely we have to divide on both sides. So megawatt divided by MVA base. So next thing is per unit impedance. So Z per unit, Z is ohm and divided by the Z base value, and similarly Y per unit. So we can calculate by dividing the Y base. So next important thing is the susceptance, because in PSSE, in the transmission line parameter, the value that we entered is RXB. So that's resistance, reactance, and the susceptance. So susceptance is the basically reciprocal of charging, your charging value Y. So what you do is you calculate the C value and multiply by 2 pi FC. Basically that is XC. So basically reciprocal of XC is a B. So that's actual B. So divided by its y base, you can calculate the B per unit. So in this way, you can calculate RXP and then put in the transmission line and you can put in the transformer. This basically these are not on the different basis. These are the per unit values that are calculated based on the given data available on the nameplate. Okay, next is the calculate DC and single phase per unit equations. So if you are doing a single phase analysis, so only the square root of 3 factor of square root 3 will be eliminated in all equations, and all equation remain as it like in three phase. You can see y base is same, z base is same, only the square root 3 is omitted. And similarly, if you want to convert your data into per unit values, so you can find the per unit V per unit is equal to kV divided by kV base, and the real power, similarly megawatt divided by the MVA base. In this way you can calculate all these values. And then last one is the very important in per unit. So converting up from old MVA base to new MVA base. Okay, so if you are interested in one component have a old MVA base and now you are converting to the new value, so MVA per unit new is equal to, so the value is all values should be in the per unit. So the value of per unit is given MVA per units, that is in old. So you need to convert, you are converting that old value into new value. Simply divide the base new value divided by the base old value and multiplied by the MVA per unit old value. You will get the new MVA value. This is only for if you are mostly doing a inertia calculation for a machine of a different MVA. So you can calculate new MVA on this in using this formula. Okay, and next is the convert of impedance from old base to new base. Now the base is changing and now you are calculating the impedance like the in the transformer case, like in the transformer case. And what we do, we say that the initial it has a value of x source of 10% at this base. Okay, now we need a new value of at sorry we need a new per unit value at a 100 m base. So if the initial value has 10 MVA, so you can calculate new value at 100 MVA, simple using this formula. So if because if voltage is the same, so you can use calculate this the same, this ratio use as a 1, so 1 square it will be cancelled, simple. So MVA base new divided by MVA base old multiplied by Z per unit old, you can calculate your this basically this value of your n at 100 MVA. And one more important thing is that PSSE will not tell you that that mean you are making any mistake in the data entry. No, your result will be affected. So when you will see at the results, the flows will be different, which will be basically there will be a mismatch in the actual flows and the PSSE flows. So then you will go back to your network and you will see, debug your network, you will see the per unit impedance will not correct calculated correctly. So this is important. You should make sure that all these things, all these information are entered correctly in the PSS. And next is the convert tap position from off load to open circuit voltage like tap new. Because if we are calculating new tap value, so for this purpose we need HV voltage and then offload voltage and then system bus bar voltage of LV and HV and then 1 plus tap old. So tap old and tap new. So tap old is basically linked with all these parameter and you can calculate the tap new percentage value, basically the new value of like we put in 1.025 1.0 like in our. So what we do in PSSE, initially we convert our reactance into 100 MVA base, then we can use the same tap ratios of at given at on 100 MVA base that we are already calculated. So no need to calculate for each position, simply. So these are the analysis. So we can use these formulas, make by using making use of these formulas we can calculate mean per unit values, and we can calculate new reactance value on new base, and you can calculate the new MV of generator using these formula. And also we can calculate per unit of any single single component also, like in the transmission planning RXB. per units using the previous sheet also. So I think the per unit questions are clear. If anyone have a question now, you can ask regarding per units, then we will move to transmission planning. I think you should ask a question.